Hello, hello everyone. Thanks for staying so late. Welcome to fireworks lighting up the sky with millions of spark. My name is Thomas Gerber. I'm a director of engineering at Salesforce Einstein. And today I'm going to take you on a journey about how we built the compute service powering Salesforce Einstein and how we made sure it would scale. The service itself that I'm going to describe is interesting in its own right, but I think like the journey itself and the decision we were faced with and how we made those, I think that may be even more interesting for you. So first, let me quickly describe what Einstein is. Simply put, Einstein is the AI layer of the Salesforce platform. It enables our customers to leverage their trove of data to predict, discover, recommend, and automate. I'm going to give a few examples of what that means during this talk. But our compute journey today, first we'll talk about multi-tenant predictive applications, what that is, why it's a key to unlock AI at Salesforce, how did we make it happen, and why does it mean that we have to run so many Spark jobs? Then I'm going to go to describe how we built those first few applications and how we optimized for speed and agility, because at that point the idea was to prove that it was possible. And what we learned. And finally I'm going to take those learnings and describe how we designed a compute service that would make building and operating those applications a lot easier. So, multi-tenant predictive applications. Before I go into what that is, I would like you to humor me for a second. Imagine you're a data scientist, not a good one, okay? And you work for company Fubar. And I'm your CEO, and I'm coming to you, and I say, hey, I need you to help me with something. I need you to take all the leads we have in Salesforce, and you do your magic, and you give me a score so that we can order the leads for the sales rep, and they will start from the top. All right. Since you're a good data scientist, what you will build is a pipeline that looks something like this, where you will do feature engineering, model training, model evaluation, and then once you have a good model, because you're a very good data scientist, you'll find a way to operationalize it and essentially use it to score any new data that comes in. Okay, great. That's awesome. And if you integrate all of that into Salesforce directly, because you're also an awesome Salesforce developer as well, you know, it might look like this. This is actually an actual feature that exists in Sales Cloud, the flagship product of Salesforce. Okay, so far so good. Now, second problem. Imagine that you work as a data scientist for Salesforce. And I'm asking you, because I'm Mark Benioff, I'm telling you, hey, can you create predictive lead scoring, but for every single customer? So you might be thinking, okay, well, you know, I can simply think of all the customers of Salesforce as one customer, and I will do the same thing I did at Fubar. Doesn't work very well for two reasons. Number one, legally, you cannot do that. Salesforce cannot use given customer data to build a global model. So that's a no-go. But even if you could, it would probably not be a very good idea from a data science perspective, because customers use Salesforce very differently. And so by using a global model, a lot of your customers might have very poor accuracy on their scores. So then you might come back to me and say, well, okay, fine, I cannot do a global model, but maybe what I can do is simply use the same code, if you will, that I built at Fubar and just apply it tenant per tenant. Well, actually, that you're getting somewhere. I mean, that is already better. But then I'm throwing another hurdle at you by telling you that a lot of customers at Salesforce customize Salesforce, the Salesforce instance. And the way they do that, they add fields, custom fields to objects. And for example, company Fubar might have a field called has received marketing material, which is a Boolean field. And obviously that field carries a lot of signal, right? The score should be higher if someone has read your marketing material. The problem is it's a custom field. So how can you make sure that you leverage that so that your customers get as much accuracy as possible on your scores? Well, this is where Einstein comes in. If you think about what you would have to do in order to get a good model for every single customer, you would have to do data sampling, feature engineering and selection, model selection, and so forth. And this is what we managed to automate with Einstein AutoML. Einstein AutoML, we talked about it at various conferences. Sometimes we call it Optimus Prime. We gave actually 2 or 3 talks here about specifically that library. We also gave a keynote at Spark Summit Europe. My colleague Leah McGuire did that about low-touch machine learning. It's really great. I encourage you to take a look at it, but it's not what I'm going to focus on during this talk. Just trust me that it exists. So what it means is now, even though customers of Salesforce use and customize their objects in Salesforce differently, with a single code base, I can write something that will generate pipelines for each tenant and provide lift, provide good predictions for all of those customers. And essentially, I managed I enable data scientists at Salesforce to build multi-tenant predictive applications, which translates into feature. And the key term here is multi-tenant. Okay? So predictive lead scoring that we saw just before is such an example of multi-tenant predictive application at Salesforce, developed by Salesforce developers. Another example would be case classification in Service Cloud. Service Cloud is used for service folks to deal with tickets and customer questions or complaints. And the idea of case classification, for example, is to automatically route a ticket as an entry into the right support person. That's another example of learning. So back to my pipeline. So now that pipeline represents essentially 2 flows, modeling and scoring, if I simplify a little bit, that need to run for every such multi-tenant predictive application for each of its customers that subscribe to it. Okay? I need to run it as a Salesforce platform engineer. I need to run it for all of the subscribed customer of that feature or of that application, right? So everyone that buys predictive lead scoring in Sales Cloud, well, I need to do that. And then for all the application that use Einstein AutoML, well, I need to run those flows. So it quickly gets to a very large number of flows. And something I forgot to tell you is that Einstein AutoML, I had it on the slide, sorry. Einstein AutoML wraps around Spark ML. And this is how we are talking about running many, many, many Spark jobs. The variance on the Spark jobs is actually very large, meaning incremental scoring on a small customer for a simple application, that's probably a very, very small Spark job, not what you could call big data. But modeling on a large customer for a complex application, that's probably an extremely large job. So we'll have to figure out a way to deal with that variance. So obviously the $1 million question is, how do we execute all those Spark jobs? So that was to set up the context of this talk. Now I'm going to tell you how we approached building the first few applications like predictive lead scoring that you saw on the screen before, how we optimize for speed and agility, and what we learned. The goal of the first few applications that we built was to prove that Einstein AutoML worked, right? And so that's why it was important to iterate fast on it. The tech stack we chose was Azkaban and Yarn. Azkaban for 3 reasons. First off, it had the right semantics for what we wanted to do. It has a high-level concept of project. A project is a collection of workflows, and a workflows is made of jobs. You can execute a workflow, you can trigger it, or you can set it on a schedule. And you can see how that maps with what we're trying to do, because I can have, for example, for a given application like predictive lead scoring, they can have 2 projects. one modeling and one scoring, and each flow is essentially the work for that particular customer of theirs. The second reason is it had out-of-the-box Java support, which is nice because when we had to deal with ETL, those were Java jobs, so we were happy to have Java support. And then it was actually very easy to add support for Spark, just telling Azkaban how to submit a Spark job to Yarn. Another interesting feature was that we could extend Azkaban to add a Yarn cluster manager, meaning something on a per project basis that could control or create or destroy a Yarn cluster. So that was also very nice to have. And finally, and probably one of the main reasons, we had engineers at that time that had experience with Azkaban. So that played a huge role, again, in the context of trying to iterate very quickly. There are other workflow engine out there. Airflow, Luigi are just a few, but this is why we chose Azkaban. So how did we execute? We decided to build one team for each of the first applications that we wanted to build. So predictive lead scoring that I showed before had a team. And we gave each team its own backend, meaning like each team had its own Azkaban cluster, each team had its own Yarn clusters. And the reason we did that was because we wanted to make sure they could iterate quickly, and so we wanted those teams to be independent. With that, it was fairly easy to get to something like 10K Spark jobs per day, nothing major. But there's obviously a price to pay for that speed and agility, and that is that applications have to take care of everything because they own the whole backend. And if I dig into that in a bit more detail, one of the things I had to care about is multi-tenancy orchestration. Remember, those apps have customers, Salesforce customers, subscribing to them, right? And it's a responsibility of the app to keep track of who is using the feature and making sure they register the right flows on Azkaban. Another thing they had to do is to make sure they were configuring and using the Yarn clusters properly. And that's not always a trivial thing to do, as we'll see in a few slides. Another thing was they had to make sure that the Spark configs they were passing with each Spark job was correct enough for the Spark job to run at all or run in a fairly efficient manner. So they were responsible for all of that. And so interestingly, what that means is the apps were self-reliant, meaning they were able to iterate very quickly, but most of their code was not about machine learning. And so fortunately, we were able to show that the concept works, Einstein ML works, and that had two consequences for those apps, first few apps, and the app teams that were building them. The first one is more tenants were subscribing for those existing apps. And the good news is scale was not hard because it leveraged the strengths of the underlying stack. The main problem that we faced was the fact that we were doing very inefficient Spark Summit. Azkaban spawns one JVM per flow it runs. And so when that flow had a Spark job in it, Azkaban would simply do a synchronous call to Yarn to submit the job and wait until the job completed, either with a success or a failure. And that's very inefficient because on the Azkaban side, you have this JVM just sitting there doing nothing but waiting. So we knew that long term, we would have to replace this by something that's more thread-based, like an ACA actor architecture, if you will, of something that would either replace or improve on Azkaban. But at the same time, we didn't have to do that because you can just add more Azkaban executors. So you are still very inefficient, but in terms of scale, it scales fairly easily for what we wanted to do. Another consequence of being successful for an app meant that those apps started as pilots and they became GA, right? General availability for all customers of Salesforce to buy. And so that meant that before that could happen, app team would have to spend cycles on reliability, meaning making sure that SLAs were met and that meant usually two things. One, focusing on monitoring and alerting. Fortunately, we have a very good infrastructure team that that provided Datadog, Sumo, PagerDuty as a service, so that was great. And then also a lot of logic in their app code just to deal with edge cases, which we didn't care too much about in the pilot phase because there were no SLA essentially, but that we cared about as they were about to become GA. But it was fairly easy to go to 100K Spark jobs per day and 500 million almost predictions per day. So pretty cool. Very happy, those apps are successful. What does it mean now? Those first few apps, okay, energy and sweat, but they work. Obviously, we want to do more, right? And so I'm going now to the meat of the talk, which is about how did we design a compute service to execute all of that. So what's interesting is it's a new dimension now we have to care about, right? We talked about how existing app would get more tenants as they were successful, how they would slowly go into GA. The new dimension now is like we want more apps, right? And that means that if we want this dimension to scale, we need to make sure that they don't have too much work to do to get there. And that means that we started building the Einstein platform. Einstein platform had different teams working on different components of the platform. To name a few, real-time, for example, would become something. And my colleagues, Carl and Jan, did a talk yesterday about real-time scoring in a multi-tenant environment yesterday, right here. ETL as a service is another such component, so that applications don't have to care about getting data ready for modeling. We can do that on their behalf. Application lifecycle management is another example, meaning essentially a framework for an app to make sure that it's very easy for them to go GA because they follow a framework that takes care of the reliability. But one of the important pieces was the compute, right? You need to execute those Spark jobs. And more specifically, we needed a batch workflow processing service to run those flows, those modeling and scoring flows for all apps, for all of their customers that subscribe to them. What would that batch workflow processing service, be responsible for? Well, for one, it would need to reliably, and by reliably we imply SLA, and we reply the operating aspect of things, they would need to reliably run all those jobs and flows. They would also be responsible for scaling the service as the number of applications grew, meaning features like PLS, a slew of other features were coming on, and the number of tenants using them, customers, using them grew. And finally, it was also responsible for controlling and lowering cost to serve, because after all, we're in the business of making money, so it's important to find a way to make predictions in a way that makes sense from a cost perspective. So again, the very interesting question is how? One of the first instincts you might have is to say, can we just operate a multi-tenant version of the existing stack? Essentially, Azkaban as a service. Instead of having each team use its own Azkaban cluster, maybe they can all use the same Azkaban cluster that the team responsible for compute operates. And voila, magic. Well, that's an interesting idea. It's tempting. It's tempting because actually Azkaban has the top level notion of project has ACLs associated with it. And so that's a good kernel to try to get Azkaban to be multi-tenant in applications. You could say, okay, predictive lead scoring, those are your two projects, and we set ACLs for you, so only your team can access it. And then case classification, those are your two projects with a different set of ACLs, and so forth. And besides, all applications that we had developed so far were running on Azkaban, so the migration path was very easy. They just had to point to another Azkaban cluster, the final Azkaban cluster, if you will. But we already noticed, that Azkaban had limitations, namely the 1 JVM per flow, very inefficient, but also Azkaban was not doing a lot of smart things regarding resource distribution, meaning figuring out a way to get the jar onto the Spark executor from Azkaban. And there was also no resource allocation intelligence, meaning Azkaban is very dumb that way in the sense that it doesn't try to optimize the amount of resource it gives to your job. So we knew that we would have to fix that eventually, but if we provide Azkaban as a service, then we are forced to deal with that in the context of Azkaban, because Azkaban API is now our main API if we do that. And so we're kind of stuck with it if you go down that path. Another set of problems is that providing Azkaban as a service does not address a lot of customer cost problem. And by customer, I mean app teams. I'm quite sure most of you here encountered problems like infrastructure limit reached or API rate limit on Amazon or Google Cloud Platform, for example, because you had a bug somewhere in your code that interacted with your infrastructure. It's very easy. If Amazon support got $1 every time someone says, I really need you to put that limit a little bit higher, and yeah, no, it's not a bug in my code, it's on your Amazon platform. I mean, I would be rich today. So it was very easy for customers, so for the app teams to go into those kinds of issues. It was also very easy for teams using Azkaban to go into disk or database full. Mostly because we were dealing with Uber jars, because most of what we do is Spark jobs, and Spark jobs require Uber jars, and Uber jars are 3 orders of magnitude larger than a regular jar file if you were just running Java jobs. So it's very easy to misuse or abuse features there and get into trouble. And finally, the last kind of troubles that the first apps encountered and that we were sure would also happen with Azkaban as a service would be misconfiguration of Spark jobs, and just put a config that would make your Spark job either extremely slow or fail. If I try to put that in another way, if I had to provide Azkaban as a service that could leverage 100 times the growth of tenants, meaning customers, for existing apps, meaning I don't increase the number of apps, but I increase 100 times the number of customers using those apps, that would actually be fairly easy, because I can simulate what that looks like, right? I can stay in front of the wave, I can anticipate, and now the only thing that's left to do is technical stuff, which is not necessarily easy, but at least I know what I have to work on, and so I qualify that as relatively easy. But if you ask me to build Azkaban as a service that can support just 10 times the growth in number of applications, and not even tenant growth, just 10 times the number of applications, that's a bit trickier. It's trickier because every capability will be broken or abused by your customers. It's just a matter of when, not a matter of if. And so as such, it's very difficult to anticipate where it's going to break next. So this is hard. And unfortunately, that's the one we're caring about. It's a hard one. And so even though we were at 100K Spark job at that point in time, I want to reemphasize that it's not going to 1 million or 10 million Spark jobs that's hard, because the two examples I just gave both increase the number of Spark jobs that you're doing. It's what you want, meaning in that case, the fact that we wanted a lot more apps that was causing an issue. And so we decided, Azkaban as a service, no. Let's think about what batch workflow processing would look like if we could design it, I would say, more from scratch. And the main thing that makes this possible was to take control away from the customer. Again, just to be clear, customer in this context means the application using Azkaban. Lesson number 1, less freedom makes it easier to scale. Imagine if you provide to your customers with a lot of degrees of freedom, it's going to be very difficult, very similar argument I just made 2 minutes ago, it's going to be very difficult for you to figure out which direction you're going to be pulled into. And if you're unlucky, you will be pulled in many directions at once. And so you're necessarily reactive in that model. If you provide less degrees of freedom, then you know exactly when your system is going to break next, and you can focus on it. So not saying it's a walk in the park, but it's at least a lot easier, and you can be proactive about it. And you can schedule your work a lot better and so forth. So if we consider the batch workflow processing service, what that meant is we wanted to give customers no awareness of Azkaban or anything like it. We wanted the customer to have no awareness of any yarn cluster, or even less control of a yarn cluster. And we wanted the customer to have no fine-tuned control over Spark settings. This is supposed to be handled by us, the service team, in a large, complex, hidden compute layer underneath the service. So we are abstracting that away. And that is important because now customers cannot break things by using those systems. We can, again, it's not easy, but at least it's under our control now. Lesson number 2, weaker contracts makes it easier to scale. Imagine you have a problem with your cable box at home. And you call your cable provider, and they ask you, hey, when do you want a technician to come by your home? And you say, I want it to come by 5 p.m. next Thursday. And you're like, great. But that's not what happens, right? They're going to tell you your cable technician will come to your home between 8 a.m. and 6 p.m. either Wednesday or Thursday or Friday. We don't know, and you need to be there. Well, sucks for you, but it scales for them, right? Because it gives them the leeway they need to get the field operation right. What does it mean for a service? Well, let me give you a couple of examples. First, we said we will not allow customers, meaning the applications, to give us specific time at which they want flows to run. They can only tell us how often. Okay, so they tell us how often, not when. The second thing is we are explicitly making no guarantee that we won't interrupt their flows. Meaning like we reserve the right to interrupt a flow for whatever reason. That means that their flow must be idempotent, meaning like the flow must be designed in such a way that at the next iteration it will catch up, if you will. We felt okay asking for this because it's actually a best practice in the world of data processing. You want your flow, generally speaking, to be idempotent because it's very frequent for something like that to fail because it's a long-running flow. And so we felt fine with it, and those first two were actually compatible with the SLAs for the multi-tenant predictive applications that were being built and shipped as features to the customer. And so we said, let's not go, where we don't need to go. Finally, the third thing that we did is add governor limits, and that's actually a fairly standard practice for the whole Salesforce platform, meaning like we reserve the right to not support your use case because it's too crazy. And so if you try to run something that takes too much resources, we take the liberty to just say no. And if I can quote Spock, I would say the need of the many outweighs the needs of the few. Yeah, someone gets it. Okay. So the main lesson here is that it's actually not, and I'm sure you're all fine engineers, it's not engineering skills that drives the ability to scale. It's product that drives ability to scale. And maybe you need those crazy requirements, but maybe you don't. And my suggestion to you is that if you have a scale problem, before jumping into trying to solve it, try to figure out if you should be giving all those freedoms and guarantees and commitments. Maybe you do, maybe you don't, but it should be an explicit decision, right? And that's why I'm saying product drives the ability to scale. Let's ask ourselves now, does it make applications easier to build? Because that's, why we were doing this in the first place. So let's take a look at the application now with this batch workflow processing service as we described it. So app team uses it. use it, and essentially what they can do is they can add a flow with a schedule or remove a flow, if I'm being very generic, right? And that flow, we don't care what it is, they can just submit it. Well, something interesting is they still need, so they don't have to care about Yarn and Spark anymore, but they still have to deal with their multi-tenancy orchestration. Remember, that is the fact that they need to track who their customers are and make sure that they register the right flow. So maybe there is an opportunity there. Could we find, instead of just the service as we describe it, could we find something even more constraining and valuable for the customer? As I said, apps were writing a lot of scaffolding to deal with the fact that they were multi-tenant. And we're not doing this in a vacuum. Remember, there are other teams that are building other components of the platform. For example, ETL as a service was one such team, and obviously it needs to run somewhere, right? And somewhere would be that service we're building. And application lifecycle management that aimed to be the framework for an app also needed compute. So they both have the same problem as an existing app. They also need to deal with the fact that they are multi-tenant. So can we figure out an interface that could benefit both existing application and future high-level services? And this is what we came up with. Instead of just allowing applications and services to submit flows, we asked them to submit workflow templates, which are fairly static, and configs, which represents their customers' specific parameters. And so those templates and config are declarative, schedule-based, and provided by the customer of the service, meaning the application or the higher-level services. And it's the responsibility now of that service to instantiate, meaning generate and execute all those flows on a given schedule. So it's a template-driven, multi-tenant workflow processing service. Template-driven, it's clear now because of workflow template. Multi-tenant because the service is multi-tenant in the sense that it has multiple apps and high-level services as customers. Workflow processing service. It's a long name, but I think it's the best I've found. Yes?
Real quick, is that second part on the right, that's done
by the service? Yes. Okay. Yes. So the service expects templates and configs, and it deals with all the rest. It does the Cartesian product, if you will, between templates and configs. And what's interesting is it maps very well to some notions around application. For example, an application or a high-level services, you can see it as a set of workflow templates that defines, the customer. A workflow template is a static DAG, which is actually a good thing in the sense that it's very close to what we had since the beginning using Azkaban, right? A set of jobs with dependencies. A template modification essentially corresponds to an update or an upgrade of your application or high-level services. So we have this notion of lifecycles that kicks into it. A config is the parameters or overrides for a specific tenant of the application or the service. And when you add a config, it essentially means that you have a new customer for your application, right? For example, I added Orange, and therefore I essentially instantiated a modeling flow and a scoring flow if I'm using predictive lead scoring app as an example. To show a bit more details, simplified JSON here. On the left and in the middle, I defined two workflow templates. Again, I'm using predictive lead scoring as an example. Let's say it has a modeling template that is by default run daily, and it's made of two jobs. A Spark job that computes the best model using Einstein ML with some properties, and then a full rescore using the new model on all the data for that tenant. The scoring template has a faster schedule every 5 minutes. First, a Java job to fetch the new data, and then a scoring job that uses the model and scores the data. So those are two templates. And then, let's say your FUBAR company buys the service. You simply add a config for foobar, which has a tenant ID, and then it can or cannot, depending, override certain settings. So for example, because foobar paid a lot of money, they could override the modeling schedule and do it every hour instead of every day. And then they could override certain properties as well. They didn't touch scoring, so that means that they are using the default, they want us to use the default config for scoring. And that's it. And this has value because now for the customer of the service, meaning the application and higher level services, compute is completely abstracted away from them. It fits both application and future high level services, and it's a simple, opinionated interface. And this is important because the new design, instead of just batch workflow processing system, the new design of templates and config has benefits. Number one, because of templatization, it actually encourages the customers to write idempotent flows, because I'm forcing them into that model. Another thing is, if you think of template and config now, those are actually two good hints on how big the job is going to be. And this is something that's fairly easy to learn for the service, right? Meaning we can derive fairly easily that modeling template is going to take a lot more resource than scoring template. I can derive that config A for foobar is going to, because foobar is much larger, it's going to usually take more resources than whatever small startup with a lot less objects will take. So I can use that to do a lot of smart things in that hidden layer. And so compared to just the batch workflow service that we described just a couple of slides before, it's even easier to scale. So how does it, applications and high-level services use the service, and essentially what they can do is add config when they have a new subscription, remove config, and update templates when they do an update. And what's really funny is that the template-driven multi-tenant workflow processing service still actually uses Azkaban in the hidden layer and Yarn, right? For example, we started adding auto-scaling capabilities to Yarn, the use of Yarn queues, Spark dynamic allocation, auto-staggering flows to be a little bit smarter in how we distribute the work within a time period. And what's really cool now is that we started with a similar stacks that we're familiar with, again, Azkaban and Yarn, but I can swap everything whenever I want behind the scenes without breaking any contract with our customers. So the road ahead is still hard. We have a lot of work to do to, again, get away from one JVM per flow and go into something more thread-based. There is a lot we can do around resource allocation and dynamic scaling. There is a lot we can do into smart scheduling and staggering those jobs and flows. And I'm hoping to be here next year at Scale by the Bay to tell you exactly what we did. But what I can tell you is it's at least a much more defined problem now, as opposed to if I had just tried to operationalize Azkaban as a service directly for my customers. And those are the takeaways. Scale is as much a product matter as a technical one. The more control you give to your customer, the harder it is to scale. And what I encourage you, number one, is to make sure that you make those trade-offs explicitly, because it's extremely likely that you don't have to go that far if you think about it. Number two, and that's probably even better, being opinionated can allow you to take control away from the customer, meaning compared to the naive batch processing workflow service, I don't allow my customer to register arbitrary flows anymore. I force them to be in that framework of templates and configs, right? So I take control away, and so I make it easier on me to scale while creating value. And this is very important. You have opportunities there that you can leverage. Again, the benefit for the customer is that they need to think in terms now of templates and config, and that simplifies actually a lot of what they're trying to do, because they're starting with a page that's less blank, if you will. So try to find those opportunities because they make your life a lot easier. That's it. Thank you. Ready for questions? And I have socks.
Get socks.
You have socks.
Great talk.
Thank you.
So I'm thinking about adding specialized hardware to this picture. So let's say I could run your Spark jobs on FPGAs or GPUs by magic, which in fact I can. Can your system reason about how to resource allocate those things?
It's a good question. I wish we were that far. Maybe we will one day. But I don't see any reason why we couldn't at least approach the problem. Meaning, again, the whole purpose of the talk is to make sure that you define your surface as narrowly as possible so that you have time to care about those things. Because if you think about the long-term objective of the service that I'm describing is to be reliable, be scalable, and be efficient, right? And if I'm always dragged into scale issues because customers are using my product in a crazy way, I won't be able to work on being efficient and being smart. And so, at least with what we went through, it's much more likely that it will be hitting those problems, meaning that what you described gets to the top of the list of what matters. Does that make sense?
Yeah.
All right.
How do you handle learning and monitoring for the users, like the customers?
How do I handle learning and monitoring for the customer? Meaning, can you
So
specify?
like they register these,
Yes.
so this is the service, right? They register their templates and
Yes.
they,
Oh,
how they know
yeah.
when things break, when they work, or like, is that service at all?
Yes, it's part of the service. I just didn't go into it because I didn't have the time. But yes, customers can query the status overall of their template, of their config, and we take care of aggregating that together. But that's a fairly easy problem in the sense that it's simply a few queries in a database that holds a state for each execution, and you.
I'm thinking like if they make a change to the template, and it kind of causes like a systematic failure of all their jobs. Like, how does something like that? So like say they change one job, all those jobs are breaking, all the
Yes.
they get flooded with alerts or kind of more passive learning.
I say it's a work in progress, and so I would say probably yes at this point, but maybe not so in the future. But I think again, it's the same thing now. I can focus on adding those smart features, and sure, they're very valuable. And I think like as long as I'm not distracted with scale issues, it's very easy to focus on those. So it's at this point, it's a product question. Oh no.
Relax the scheduling requirements to your end customers, such as you don't allow them to specify when to run jobs.
Yeah.
However, I was talking to your team about a release scoring system. If
The use of, sorry.
I was talking to the team about
Yes.
the release scoring application you guys are building, if you only allow them to specify once per day that was executed, you run 2359, and then you run it again next day 00.01.
Yes.
Then your result is literally useless in that case.
Yes, I understand the point you're making. That being said, it's about the contract. How I do it right now is actually fairly irrelevant, meaning like I can still do things in a very inefficient way because, another example is I'm still using Azkaban. I'm still using a lot of inefficient things. That being said, I'm still not making promises, and I think that's the important part. So even if I do it that way, there's a point in the future where I will be a lot smarter, if you will. And that's without taking away anything from the customer because I'm not making the promise today. Does it make sense?
Yes, you are not promising, but on the other side, is that from business use case, I need to make sure that my data, all the stuff I get from the system is usable. Because 2359 execution and next day 0.01 execution
Yes.
It's still the same result, and my team cannot act on insights on a given day.
Okay, the only thing I can tell you is that the way we design the system meets SLA. So that's the overarching goal of the service, is to meet SLAs. Now, I'm not completely sure who you talk to or what, but I would say my point is mostly about not making promises that you don't need to make. And so as long as it fits the SLA, I think you're good. Sorry, I don't have any socks anymore.
So that's fine. I'm curious. So on the question of like monitoring and that sort of thing, if someone needs to test their template, but you're not allowing them to choose when it runs, do they just have to make their change and then submit it and then just like wait an hour?
Yes. No. So I was actually exaggerating the point. I actually let people trigger flows, but it's necessary through an API call. Meaning what I want to and I can rate limit those, right? And so I give the capability. I was just forcing the point that I don't want to make promise that I really don't want to make. But we are actually authorizing this. And there are other use cases that require that. For example, sometimes the end customer of Salesforce can request a model to be rebuilt. And so that does a call to say, hey, execute this now. So I'm actually allowing this. I just don't want this to be the default way for the service to be used. I want the schedule to be the default way for the service to be used.
Also, that will happen in a test environment, right?
Yes.
Testing, production, you still have the freedom to do what you want.
Yes. Well, yes.
Any other questions?
I mean, if you have time, so this was for batch, but for streaming, do you have an entirely different setup?
Yes, and actually my colleagues gave a talk here yesterday about that very topic. The interesting, and maybe it's a follow-up question, I think like, is there any kind of overlap between stream and batch? I mean, can we maybe use something similar? Maybe. Maybe there could be a unified batch and streaming service in the future. As with anything, I think the most important thing for us is to move forward incrementally. And so right now, those are two separate initiatives. In the future, it might become one or not. We'll see. But good question. Because the semantics are actually fairly similar, right? A DAG looks very much like a storm topology, say, right? So there might be something there that would make... the goal is to make real-time scoring versus batch scoring seamless for the application owner. So we might get there.
All right.
All right.
Thanks, Thomas.
Thank you.
That's it to this stage. See you guys tomorrow.